Okay, let's move on to the next data set. So that's going to be the San Francisco jobs data set. And let's reconnect to the SQL database. And then we're going to fetch all the data from the salaries table. And we explored this and did some filtering. So what we ended up doing basically is selecting only the total pay benefits and the job title rows. And then we cleaned up the not provided values in job title and the 0.0 values in total pay benefits to make those be not a number. And then we dropped all the rows that had not a number values in them. So what we ended up with was this data here. And it includes job title and total pay benefits. So let's get started with that. Now, the first thing I want to look at is the most highly paid jobs. And there's a method that I can use called nlargest. So if I start with filtered, and then I do .nlargest, and let's say I want the top 20, and then I can give it what column I want the largest values by. I think I'd probably do the right thing with the default, but I want total pay benefits. So this is going to be the top 20 rows with the highest total pay benefits. And you see we have some number of rows coming back. That looks like about 20 to me. And then for presentation, probably something like a bar chart is going to be the best way of viewing the data. Just as with plotting a line chart before, we can use the plot method off of a data frame in order to plot the data. Now, with a line chart, the index of the data frame is used for the x-coordinate, and then any numeric columns in the data set are used to plot trends on the y-axis. Bar charts work just the same. Whatever you have as the index is going to be on the x-axis of the graph, and then any numeric columns that you have are going to be plotted as bars on the y-axis. So this is already sorted in descending order by total pay benefits, and it's the top 20. So all we need to do here is take filtered, actually the nlargest 20 from filtered, and then we're going to set index to be total pay benefits. So that's going to be the x-axis, and then we're going to plot a bar graph. And let's take a look at what we get. And we got an error, so let me take a look at why. Oh, no numeric data to plot. Actually, the x dimension should have been job title. So let's set job title to the x-axis, and then total pay benefits is going to be the y value there. So that's what we want. All right. So now looking at this data, we see that the highest paying job is the general manager for Metro Transit Authority, and then the police captain, deputy chief, assistant medical examiner, chief investment officer, and so on. And then lots of jobs in this $400,000 range. So now another thing we might want to look at is actually the distribution of salaries. So we see that there's a whole relatively few jobs that are over $500,000. There's only 3 of them. And then there seems to be a fair bunch of jobs in the $400,000 range and so on. So what we can look at is the distribution of salaries, and I can use the same filtered data set to do that. So we're going to start with filtered. And then what I want is to see the distribution of values in total pay benefits. So I'm basically going to ignore job title this time. And to do that, you can plot dist for distribution. And let's see what we get there. Yeah, so I need, that's actually histogram, not dist. Okay. So that's giving me a histogram that shows me the frequency, the number of values that fall in different ranges here. And by default, what it does is it takes the lowest value in what I'm plotting, which is total pay benefits, because it's the only numeric column. So it takes the lowest value, which is 0, or a little bit more than 0, and the highest value, which is 500 and some odd $1,000, and then it breaks it into 10 ranges by default. So 10 bins, and then it counts the number of values in this column that fit in each bin, and so you see this kind of distribution. So there are about 40, maybe 42, 43,000 jobs that pay between 0 and, I'm going to say this is maybe 70,000 a year, 60,000 a year. And then the most jobs are actually between, say, 60,000 a year and maybe 120 or so. And there's over 50,000 jobs that fall in that range. And then they fall pretty quickly after that. There actually are very, very, very few jobs that pay 300,000 and up. Now, if I don't like this particular set of bins, I can adjust it by passing in a bins argument. So we'll say bins equals 20. And then we can see that there's actually a big glut of jobs that are, under 20,000, and then sort of a bell curve for the rest of the jobs that peak around 100,000. So about 100,000 is the most common salary. And then these jobs, if you actually look at what's going on in the data, so let's go ahead and take a look there. So we're going to select, actually I'm going to start with filtered, and then I'm going to select filtered sub total pay benefits less than, and let's say 10,000. And usually what we're going to see, well, at the top, we still see some student positions, internships, and museum guards and things like that I guess are fairly low paid. But we see at the bottom some of these jobs where it's like 724, 1289, and so on. And these are almost certainly hourly employees. So let's actually drop this down to 100. And public service aid, special programs, senior deputy sheriff, 98, public service trainee, 98, and so on. So it seems like there's two different scales here. There's some positions that are only paid on an hourly basis, and that forms this glut. And then jobs that are paid on a salaried basis, and that forms this sort of bell curve here. So let's see if we can actually find where the breakpoint is. I'm going to go ahead and let's take 0 to all the jobs under 1,000, and then let's plot the distribution of that. So plot hist, and because this is actually including a job with a negative salary. But see, the distribution is not telling us anything in particular. There's sort of a big group of people with under 200, and those are all hourly employees. So let's look at under 200 and see if we can see anything. No, I don't really see any easy way of telling who's salaried and who's hourly here. So what I'm just going to do is let's go ahead, and it seems to be, looking at this graph, it seems to be basically under 20,000. So let's skip those people for this graph. So this is going to be filtered, so filtered, and then we're going to do total pay benefits is under 20,000. And then we're going to plot the remainder of that using 20 buckets. Okay, so that's the frequency or the distribution of salaries in city jobs. Now, another thing that we might want to look at is the total number of jobs in each position. So looking at filtered again, you'll see that there's actually 148,000 positions listed. And some of those positions, like registered nurse, there's going to be a lot of registered nurses in this data set. And what we really want to know is for each of these positions, how many people are working in that position, and then let's look at what positions have the highest number of employees. So we looked at the highest total benefits here, which is just basically ordering on this one column. But what we want to do instead is basically group by the job title and then count how many rows in this table or this data frame had that particular job title. And then we can order by that and then pick the top 20 off of it. So what that's going to look like is first we're going to use a group by. And you specify the column or columns that you want to group by, just like in a SQL group by. So what this is going to do is it's going to give me one row for each distinct combination of values in whatever columns I give here for my group by. So I'm just going to group by job title. If I wanted to group by more than one column, what I would do is I would give it a list here. So I would say job title and total pay benefits, for example, and that would give me one row for each combination of total pay benefits and job title. But here I only want to group by job title, and if you only have one thing, you don't have to put it in a list. So this is going to give me a group by object, which looks like that. And then to actually get real data that I can work with, I have to tell it how to aggregate the numeric values in each of the groups that it's creating. And for this one, basically what I want is for it to count the number of rows. And if you just do count, what it's going to do is any numeric column, or actually for count probably it's any column. So any column in the original data frame, it's going to count up how many values for each group, and what I get looks like that. So job title is the thing I'm grouping by, so those are the original values. And then total pay benefits, what it's actually showing here is how many not NA values, not a value, not a number values there were, and I have 83. So why is this on total pay benefits? Isn't that confusing? Because total pay benefits is a number, and what does it mean to be counting numbers here? And this is going to confuse people. So what I usually do, and this is going to result in exactly the same results, is I add a column to the data frame like so. I say filtered subcount is equal to 1, and then I only select that one column here to aggregate. So what this is going to do is it's going to add a column to the original data frame where there's a value of 1 in each row of the data frame. And then here I'm going to group by job title, and job title is going to be in the index. And then for columns, I'm going to throw away everything but this count column. So I only have these ones here. And then to aggregate those values, I either count the number of ones, and I get so this is a slice that I'm working with. And so really what I want to do is put that on the original data frame. And you'll see that the numbers I got were basically the same as the numbers I got when I was counting total pay benefits. but it might make a little bit more sense to somebody looking at it. Now, since these values are all 1, I should get the same results if I sum those values as well, and I pretty much do. So here is the total number of positions for each of these job titles, and then I can take the n largest of this as well. So let's take n largest 20, and this time I'm not even going to specify the column just to make sure that works. And it does. And then, so these are the most common jobs in the city, common government jobs in the city of San Francisco. We see transit operator is the most common, then special nurse, registered nurse, and so on. And then we notice that there's transit operator here spelled in, this is called title case, because it's how you write like book titles and movie titles and things like that, this capitalization. But then you see transit operator again here written in all caps. And same thing here with special nurse in all caps, special nurse up there. And these strings are not equivalent. And so when you do the group by, these are separate rows. But we actually want all these things to get grouped together. So what I'm going to do, this was basically a cleaning step that we missed before, is I want to take the job title in the original data frame and I want to replace the value of job title with title case. So it's going to leave transit operator here alone, but it's going to convert transit operator to the same case as this is using. This is actually going to probably affect some of my counts up here as well. So I'm going to go up here where I did this job title replace not provided with not a number. Let's do job title equals df dot job title, and then before we saw how I could use the string method accessor by saying .str, and that gives me access to a bunch of string methods that I can apply to the column, and one of those is going to be title. So let's go ahead and execute that. And then we see that all the ones that were all caps before are now in title case, which is a little bit funky for this like I for Captain 3, but I'm going to overlook that. And then if we want to replot that, it looks pretty much the same, except the case on that. And then here's the buckets, and these buckets, all pretty much the same. Now let's run this again, and we saw before the most common job title was transit operator with 7,000, and then I lost my count here. I think I have to count and then filter. So let's actually redo this filtered here. Oh, so when I grabbed this data frame, I did not include count because I hadn't added it yet. So let's go ahead and I'm going to grab these lines and then after I add count to df, I'm going to recreate filtered, including, let's do total. We don't need total paid benefits. We do need count. So I'm going to include count in job title. Then I'm going to drop NA values, and then I'm going to group by and take the largest. Okay. So now we see that the number of transit operator positions increased from 7,000 to 9,000 because we added another 2,000 or the case was different and so on. So these should be the positions with the most employees. And let's go ahead and plot that. So we're going to plot using a bar graph. And then for that to work, we also have to set the index to be job title. So set index. Actually, we did a group by, and when you do a group by, it automatically sets, by default, whatever column you do the group by already sets that to B index. So I don't need to set the index again. And there's my graph. So we see that by far the most common position is transit operator, and then special nurse, and it sort of forms this kind of curve, which is commonly known as a zip distribution, ZIPF, zip distribution, and it was documented first when talking about the frequency of words in the word usage in texts. So you see this kind of distribution where, for example, words like the and a and occur all over the place and very, very high frequency. And then it sort of drops off, and then there's this really, really long tail with lots of individual words that aren't as commonly used. So that kind of shape is known as a zip distribution. And one other thing we might want to look at is, now that we've seen how to group by job title and order by the frequency, let's go ahead and look at the total amount of money that's been spent on each of these positions. So here we're going to do basically the same group by, but instead of just taking the sum of the count column, which is going to give us, the number of positions, what we want to do is sum the total paid benefits. So let me go ahead and actually I'm going to go and grab that. And this time I'm going to grab total paid benefits in job title. And then we're going to group by job title and then sum total paid benefits. And take the top 20 of those and plot them in a bar graph. Okay. So this is the positions that the city of San Francisco spends the most money on. And you'll notice the scale, that's 1E8, so that's 8 times 10 to the 8, which is 8 with 8 zeros after it. So that goes from 0 up to 8 with 8 zeros after it, which is 800 million. So city of San Francisco spends almost 800 million on transit operators and about 700 million on registered nurses, 5.5 million on firefighters, and so on. And then it drops pretty quickly after that. Some of these positions are relatively low wage, and so they end up farther down. But most of them just have fewer employees, and so even the extremely highly paid people, like the city manager, is only earning 500 some odd $1,000 a year. So there's one other change we could make, and up here where we were looking at the positions with the highest salaries, total pay benefits dot set index job title dot plot. So this is plotting the positions with the 20 positions with the highest total pay and benefits. Except that, as we've seen, the data set has multiple rows for different people with the same job title. And rather than just taking the 20th, this is actually the 20 highest paid people in city government, rather than the 20 highest paid positions, which would have to be based on the average total pay benefits for all of the people with a particular position. Now, it's going to turn out probably that those are identical, because all of these highly paid employees, the positions are probably, there's only one of them in the whole city. And so just doing total pay benefits for individuals is probably going to give the same 20 people as if we take the mean salaries in order that way. But let's see. So I'm going to go ahead and add another cell here, and we're going to start with filtered, and we're going to group by job title. And this time we're going to take the mean salary of total pay benefits. So here's each of the different positions along with the mean salary for all the people with that job title. We already have our change from before because we're executing this out of order. So, or no, because I fixed the title case up here. Yeah, so I already fixed the title case, and so those are all getting grouped correctly. So now that I have the mean salary, now I want to take the nlargest 20 of those, and since I only have one numeric column, it should automatically... Oh, no, I guess I actually do have to give it a columns argument. So let me try total pay. It's actually total pay benefits mean. Let me actually see what I had here before. Okay. So this is still total pay benefits. So let's do nlargest 20 total pay benefits. Okay, so those are the 20 highest paying position. And actually this is interesting. So Chief Investment Officer actually floated to the top here. It's only 5th before, but I guess there are more general managers, Metro Transit Authority chiefs. Yeah, that one actually fell to 399,000. So actually there's more than one person with this title, and the one who gets paid the most is the highest paid employee in the city, but I guess the other one gets paid a lot less, and so that brings the average down. Okay, interesting. So let's go ahead and plot that. And so those are the 20 highest paid positions in the city as opposed to the 20 highest paid people in the city.